in last two lectures we have discussed about the traditional or conventional drought like meteorological, hydrological or agriculture drought like vegetation drought or soil moisture drought. In that we have discussed about the drought characteristics like mean aerial extent, frequency of the droughts, other characteristics like mean aerial extent, mean duration, frequency, univariate analysis, then bivariate analysis, calculated the accidents probability, conditional probability, joint return period in which we have calculated end return period or return period, and then finally we calculated the conditional return period. So that two lectures are related to normal, or we say conditional or traditional or conventional drought types like meteorological, hydrological or agriculture drought. In this we will discuss about the new type of drought which has come into existence in last 5 to 10 years, that is the flash drought. So if we talk about current climatic condition of hydroclimatic extremes over India, I think I already discussed with you that we are vulnerable to drought conditions, we are vulnerable to flood conditions, we are vulnerable to heat wave conditions. Also we are observing that based on the study which is carried out by Roxy et al. In 2017, that in last 65 years from 1950 to 2015 there is a 3-time increase or 3-fold increase in the extreme precipitation events across India. So in joint to all we can say that we are vulnerable to maximum of extreme events, either in terms of flood, drought, heat waves or extreme precipitation across India. So before starting this we need to know why these types of events are occurring. So we know that due to greenhouse gas emissions there is an increase in CO2 concentrations, and due to this emission of CO2 we have change in the climatic conditions. And if we talk about the human influence also, due to human influence there is a change in land atmospheric interactions. So the combined effect of change in climatic conditions and the change in land atmospheric interactions, all these causes will result in various impacts such as change in the magnitude of precipitation, increase in the temperature, decrease in the relative humidity, soil water deficit, or we have groundwater reservoirs, so there is a depletion of groundwater reservoirs due to these type of climatic change condition or change in land atmospheric interactions. All these impacts will result in various possible extreme events we know, like floods, drought, extreme precipitation, heat waves, cold waves and different other extreme events we have. Out of which this study which will more focus on drought risk, because there are several risks associated with drought, like we have reduced arable land productivity during the drought condition. During the drought conditions we observe that there is a rapid decline in soil moisture, and this rapid decline in soil moisture is the reason to cause the flash drought. So this is one of the important aspect or one of the important risks which we observe during the drought conditions. So this rapid decline, usually in the normal drought we have decline in soil moisture, but it is not on a rapid manner. It is declining very gradually, very slowly over a long period of time. It may take some months, sometimes some seasons or sometimes year to attain their maximum intensity. But in case of flash drought there is a rapid decline in soil moisture within a very short period of time, and that will cause a new type of drought, that is a flash drought. Other risk associated with drought is insecure freshwater availability. We need to think about the freshwater availability, because in droughts we have risk of this, and due to this we have increased water related diseases. So let's focus on flash drought. So from last 5 to 7 years we have lot of news regarding the flash drought. Some of the study across globally, they claim that this flash drought is a new type of extreme weather event. Some of the studies says that it is a new type of climate change effect, because initially I think the study has been carried out across China or USA or Europe. Then further all this study related to flash drought has been carried out across India also. So based on these studies they claim that this is a new type of extreme weather event. Some of them says that it is a new type of climate change effect. But the important thing from papers we got to know that some of the studies says that even the damp condition, which are usually not very vulnerable to the normal or conventional drought conditions, like if we talk about India, the northeast India or like western Ghats, they are usually not vulnerable to drought conditions. Mostly the western India like Rajasthan are mostly vulnerable to drought condition. But some of the study carried out across like New England, this found that even the damp condition or humid conditions are also hit by the flash drought. The same thing they have done for the future, and the future projection of flash drought also suggests that these flash drought events are also increasing in the future period over the humid regions or semi-humid regions. These are the two photographs for the USA itself, and these two photographs are in period of 41 months. The first photograph is taken on 1st July and second one is taken on 11th August. So after 41 days, we have the effect of flash drought from the greenery to this condition itself. So this is the effect of flash drought within 41 days. The same effect if we observe in the normal drought, traditional drought, or we say conventional drought like meteorological or hydrological or agriculture drought, maybe this effect can happen within a month, season, or sometime year, but the same effect can be visible, can be observed in the flash drought within a very short period of time. So based on this we can say yes, we need to carry out more studies and we have to go for faster forecasting of these flash drought events according to this research itself. So let's introduce the flash drought. So if we talk about India, India is one among the most vulnerable drought prone countries in the world, with at least one drought occurred in every 3 years in the last 5 decades. But this statement is majorly focused on traditional drought, not the flash drought. This is for the conventional drought like meteorological and agriculture. But recently, recent studies have focused a new type of, or recent research revealed a new type of drought which is known as flash drought, and it is claimed as a new type of extreme weather event. So how these two are different from each other? If we talk about the traditional or conventional drought, they are very slow growing climate phenomena, because whenever we see the definition of drought, it is always written that they are very slow growing climate phenomena and they takes months, sometimes seasons, or sometime year or more than that to attain their special extent or to attain their maximum intensity. But in contrast to these traditional drought, flash drought are different from conventional drought because they are not slow growing climate phenomena, they are very fast growing climate phenomena, and they have two important parameters, that they have quick onset and rapid intensification characteristics. So quick onset and rapid intensification means the onset means the start of the event. That start of the event is very fast, very quick, and at every single time step the intensification is very rapid. For everything, for example, if we take a time step of 5 days or 8 days, every 5 to 8 days we have rapid intensification of this type of event. That's why it is characterized by quick onset and rapid intensification. And due to this rapid intensification, it causes quick reduction of soil moisture, and this reduction in soil moisture at a very high rate or very fast rate will leads to the vegetation stress. So in this study we have developed a novel approach to define the flash drought using the new type of indicator that is known as aridity index. So we have developed a definition based on aridity index. We have very common formula available in the literature for so long, that is for the aridity index, but that aridity index value we have converted into the aridity index percentile, and based on that we have developed a method. So in this we have developed a method to define the to define the flash drought based on this aridity index. And for the very first time, the flash drought impact on terrestrial ecosystem, our Indian river basin, was investigated in this analysis. Give me a minute, please. So in this study, initially we have defined the flash dot using the aridity index, percentile, and then further we have find out the impact of flash dot on the terrestrial ecosystem across Indian river basins. So these are some of the data sets used in this study. So initially we have used a precipitation data set in this study, that is derived from India Meteorological Department, which is available at 0.25 degree into 0.25 degree. Further we have used temperature data set. Since the resolution of temperature is coarse, that is 1 degree by 1 degree, but since it is available from the India Meteorological Department, we have taken it. And finally we have regraded into 0.25 degree by 0.25 degree using IDW, inverse distance weighing method. Third thing we have derived from Delhi potential evaporation, which is taken from GLEAM dataset, that is Global Land Evaporation Amsterdam model. So if you are looking for EP dataset or if you are looking for soil moisture dataset also, you can go for the GLEAM dataset. GLEAM dataset have high reliability whenever you are taking the soil moisture dataset or evaporation dataset also. In case of wind speed, we can take from the Princeton University. In terms of relative humidity, we can go for the NCP or NCAR reanalysis dataset, that is National Center for Environmental Prediction or National Center for Atmospheric Research. That dataset is available at 0.5 degree, so we have to regrade it to 0.25 degree to 0.25 degree. Then we have soil moisture dataset in this study. So we have one issue with the soil moisture dataset, that if we talk about soil moisture, we don't have in situ or observed soil moisture dataset across India. So what we have to do, we have to find out the soil moisture dataset from any satellite or reanalysis datasets. So what we have done, we have taken the soil moisture dataset from different sources. Like initially the first one is ESA CCI SM combined dataset, that is European Space Agency Climate Change Initiative soil moisture combined dataset. What is combined? Because this dataset, the soil moisture dataset from this source have three types of dataset. The first one is calculated using the active sensor. The second one is calculated or observed or collected using the passive sensor, and the third one is the combined using the active plus passive sensors. Means whatever the advantages or disadvantages of active and passive, they have combined it to make it more better. So that is the combined dataset. So we have collected that one, not active, not passive. So that is European Space Agency Climate Change Initiative soil moisture combined dataset. Further, we have also used the Global Land Data Assimilation System version 2, that is GLDS NOAA soil moisture dataset. Third, we have collected the ERA dataset. Fourth, the MERA2. I think in the last two lectures itself we have used this dataset, that is MERA2. And the final one is IMDAA soil moisture dataset. Anyone you have visited IMDA website for any type of dataset? Okay, so this is India. Which one? Active passive? Yeah, you can take any soil moisture dataset, there is no issue. Means these are based on the literature. These are the most widely used soil moisture dataset across India, across globally. So we can take any one. However, we have to use only one. So we will find out the best soil moisture dataset for our study area. So initially we don't have in situ or observed soil moisture dataset. So we will collect from different sources. You can collect from 7. I have collected from 5. You can collect from 10 sources. Then you have to apply some technical approach through which you can find out the best one. Because in the absence of observed dataset, we have to rely on the different datasets. However, if you go directly with the GLDS, anyone can ask why you have selected GLDS, why you have not used ESA, why you have not used MERA2 or IMDAA. So any of them can perform better for India, but we have to find out it. So these are some of the soil moisture data sets. So IMDAA is Indian Monsoon Data Assimilation and Analysis Soil Moisture Data Set. So this website also provides lot of data sets like evaporation, soil moisture and various other data sets. So for India itself, you can also rely somewhat to this website also. And since we have to find out the impact of flash drought on terrestrial ecosystem, so we need to take some indicator which is indicator of terrestrial ecosystem. For terrestrial ecosystem, we have taken GPP, that is a gross primary productivity GPP, and this data set has been derived from MODI's data set, that is moderate resolution imaging spectroradiometer. The thing is that this data set is available at 8-day temporal resolution. All the above data set is available either at 3 hourly or daily basis. So whatever the data set we have on 3 hourly basis, we can convert it to daily basis. So we can say all the above data sets we have availability on daily basis. The problem is that GPP data set is available at 8-day temporal resolutions. So whatever the spatial resolution we have regraded into 0.25 degree, 0.25 degree in the final version using IDW method, inverse distance weighing method. But the thing is that we are having same spatial resolution for all the data set, but not the temporal resolution. All are available at 1 day. This is available at 8 day. Okay.
Why IDW? Why not any other? We have other approaches. So is there any
No.
specific condition that we should use IDW, or is there any good rationale behind that we are using IDW? Secondly, at the temperature you said that you have used again the IDW. So at that point I want to ask what P and what K max or N max you have chosen. That is the maximum number of points possible. And then you are taking the inverse of the distances. So it may be the inverse of the square of distances, it may be cube distances, depends, right? So how you chosen that N max and the number of points inside the circle, number one, how you selected that P and on which basis you selected these?
Okay. So first of all, there is no hard and fast rule that you have for regrading you have to use IDW. You can go for bilinear interpolation itself. Whatever the method you find reliable, you can go for that. There is no hard and fast rule that you have to go for IDW only. Since I used to do that, so I use IDW. Otherwise, you can go for bilinear interpolation, or you can go for other methods to regrade the data set. Second, IDW is used because it is somewhat reliable, because if we want to find out the value for particular point like this point, so we have data set for all the corners of this room. So if you want to find out the value of this table from all the 4 points, it's better not to average all the 4 points, because that point and that point is far away from this points. So they have less weightage on this data set as compared to these 2 points. So what we do, from this point we have this corner is very near to us, so we will give maximum percentage or maximum weightage, then we will give some less weightage to that, then we will give very least weightage to all these 4 corners. So that's why this method is more suitable, more reliable. However, there are several other methods which are performing better than IDW, so you can go ahead with that also. So there is no hard and fast rule for this type of regrading process.
Second is, again, stating that problem, that we take the inverse of the distances.
Yeah.
We take the general formula is 1 upon the distances raised to power P.
Right.
So we need to select that P accordingly.
Right.
So in that case, in this case, what is the value of that P? How it has been selected?
Okay.
And secondly, we take the number of points, depends, right? Typically in rainfall data, they have selected a different radius for the different regions. So let's say in south we have 4 number of stations,
Okay.
density wise, but in the hilly area we have less number of stations. So they have increased the stations accordingly.
Right.
The less number of stations in a bigger circle as far as hilly area is concerned. So my question is, here we are taking the graded data and we are taking it to the 0.25 cross 0.25. So in that case, how this can be changed, these number of taking the number of points for a specific point. Secondly, 1 upon d raised to power p, how that p has been selected.
Okay. So since for all across India we have used the same formula. So in that usually we used to take only 4 points, neighboring 4 points. but we can change accordingly the condition itself. If we want to make the different homogeneous regions, that like hilly area we have to take more, for the plain regions we can have more sufficient number of points, that is 4. So we can do that, but in this study we have taken as homogeneous only, so we have not done separate for separate regions.
And maybe two for this study, because since we are already having the graded data,
Yes.
we are already having the uniform points.
Yes.
But then again the question which remains is 1 upon d raised to power. So what should be value of that we have in this item? Because it, as far as if I am correctly recalling, so that graded rainfall data, they have used the squared distance, inverse of the squared distance. So here what we have used 1 upon d, 1 upon d square, 1 upon d cube, and how that d can be selected. And another which is my problem, right?
Yeah.
What do you think that how many points should be sufficient enough, let's say for any climate variable over India, we are having those number of points. How many points will be sufficient to have the IDW of the entire Indian region?
Okay.
So it's just for the experience that you have done so many things. So I just want to have your opinion on that. So what do you think, what is the ideal thumb rule that let's say 300, 400, 500 or some points where you see that of course we need those scattered across the India. Let's say we are having 1000 points, but we are having 1000 points only in Tamil Nadu.
Okay.
That cannot be too representative of India. But if those 1000 points are scattered almost uniformly in the Indian region, then of course it will give a good representation of IDW. So let's say if I assume that these points are very well distributed, so then what your experience says that how many points are sufficient enough to have the IDW representation?
Majorly means, for example, if we find out this point itself, so minimum we need to have 3 to 4 points.
3 to 4 points.
Minimum near to this. But if you are saying that all the points are distributed across, for example, Tamil Nadu, and we are finding out for the central MP or that is of course will not help, even 10 points are there.
But for Indian cases,
Yeah.
we are having so many points. So how many points would you think that they are sufficient? If they are uniformly put in a good shape,
Then 3 to 4 points are more than sufficient to give this.
for all India, 3 to 4 points.
Means for any particular point we need to grade. For example, we have 4 grades like this corners, and for any of the corner like this one we have to find out, then we can have sufficient number of points required is 4.
So let's say if I'm making a graded data
Yeah.
from these scattered points, right? So how many points should I take? I mean, totality 500, 600. What do you think? I mean, like the graded data of rainfall has been made through many stations data.
Right.
So there are some number of stations, let's
Right.
say 1000, whatever. So you might come across such problems where you have dots all around,
Yeah.
which is not regularly distributed but well distributed. So how many points they give the good representation for the graded one?
Means for the good representation, more the number of points we have it obviously, but minimum we can have 4-5 points, then it can give good representation which can work for us. Otherwise, more number of points we will take, better will be the accuracy.
And in that case, how you selected 1 upon d raised to power that?
We have used from the literature that is usually used for precipitation, temperature, that we have used the squared one, which we taken from the literature. So whenever if you are going for different data set, I suggest you go for the literature. Whatever the literature suggests for that particular data set, you have to use that. Otherwise, you have to give the reason why you have selected cubic or other one. Otherwise, literature will suggest you better. Okay, so these are some of the data set. So the thing is that this data set is available at 8 day. Above all the data sets are available at 1 day. So we need to match the resolution temporally as well as spatially. So spatially we have done using the regraded method. The temporal one, what we have to do, all the above data set are also converted to 8-day resolution. So that right now we have all the data set at 8-day temporal resolution and 0.25 into 0.25 degree of spatial resolution. Then this study is yes, temporal resolution is same. Right now all the data set is at 8 day. From this slide itself, if we talk about one time step, that one time step is equal to 8 days, not a single day, because since if we are using these data set with this, it is not possible to use single day data with the 8 day. So we have to make the same resolution, either it is spatial or temporal. Spatial we have, and for temporal we have converted into 8 days, so that spatially and temporally they have same resolutions. So from this slide itself, whenever I say one time step or a daily basis, it means it is a 8 day basis. And in terms of Flashdot, 8 day we used to say octad data sets. If we use 5 days, then it is known as pentad data sets. So here we are using 8 days, so I will call it as octad data set, OCTAD, octad. So these are the study area we have selected, means all the 24 river basins across India using India virus 2014 classification. So this is the methodology. Initially we collected all the data sets which I have discussed in the last slide. That precipitation we have taken from IMD, daily potential evaporation, temperature, relative humidity and soil moisture, and based on that we have calculated the aridity index. And this is very generic formula for so long. From the literature you can see this is a ratio of precipitation to the potential evaporation. So this formula is very simple. From the literature itself we have used it. So once we calculated the AI, then we have to calculate the AI percentile value. You cannot use direct absolute value of AI. Absolute value of AI will not help you to find out the Flashdot. Once you got the absolute value, please go for the aridity index percentile values using the I think in the last lecture itself we have calculated the percentile using KS test. We have find out the best marginal distribution, in which we have calculated the different distribution using KS test. Even though some of the study also use empirical CDF, but we can also fit the data into different distribution, and based on that we can calculate the AI, that is aridity index percentile. Once we have aridity index percentile, we will use this aridity index percentile for the Flashdot computation. That I will show how we can calculate the Flashdot. So once this Flashdot detection or identification is done, we will initially go for the very first sub objective of this study, in which we will calculate the Flashdot characteristics. The intensification rate, I think I have discussed in the definition itself, that Flashdot have high intensification rate. So what is the intensification rate of Flashdot across India? Flashdot characteristics like what is the mean duration of Flashdot, what is the frequency of Flashdot, what is the maximum duration of Flashdot, what is the severity of the Flashdot, these are characteristics. Intensification means the rate of intensification or the rate of decline of soil moisture at every time step, and the triggers, or we can say the drivers of Flashdot. What are the major drivers which are causing the Flashdot to occur in India? The second thing is, the second sub-objective is related to the definition itself. Since we have developed a definition, so we need to validate the study that whether that definition is correct or not. So what we do, we will, since we have calculated the Flashdot using the aridity index, so what we do, in the same time we will take some hydrometeorological variables like precipitation, temperature, soil moisture, vapor pressure deficit, and we will find out that how these variables are behaving during different stages of Flashdot. It means before the Flashdot, what is the condition of these variables, during the Flashdot, how these variables are behaving, and after the Flashdot, how these variables are behaving. So that if we got to know that during the Flashdot these variables are behaving similar the condition which we have developed for the Flashdot, if they are aligning with that it means we have developed the definition in the better way. Otherwise there may be some mistake in that. So the third one is the ecosystem response, that if we have a Flashdot across ecosystem, then how our ecosystem is responding to these Flashdots, and finally how our response of water use efficiency of our ecosystem to the Flashdot. So in this we have not used only the water use efficiency, but we have used a new type of water use efficiency, that is known as underlying water use efficiency. So if we talk about this underlying water use efficiency, whenever you calculate water use efficiency on an annual scale or on a bigger scale, whatever the formula you know is working fine, but if you compute water use efficiency on a very finer scale like daily scale or sub-daily scale, then you cannot go with this conventional method of water use efficiency. Then in that case you have to use one important parameter in the calculation, and that important parameter is vapor pressure deficit, VPD. And if you incorporate VPD in this formula, the old conventional formula for a smaller time scale, then that water use efficiency will be converted or will be known as underlying water use efficiency. So if you are going for an annual scale, you go ahead with this conventional method of water use efficiency, that is simply the ratio of gross primary productivity to the evapotranspiration ET. So that is GPP divided by ET. But if you are calculating for a daily scale or weekly scale, like at 8 days we have a resolution at 8 days. If you are calculating at 8 days, then you should incorporate this important parameter, that is vapor pressure deficit. And if you use this VPD with this, then so since initially if we have flash drought, if we want to find out the flash drought, we need AI, that is aridity index. So initially there are 4 conditions to satisfy whether there is a flash drought or not. The very first condition is that initially we need to check that if you are starting the flash drought identification, the current AI percentile and prior AI percentile should move from 50th percentile to below 50th percentile. For example, if you are starting to find out that this is flash drought condition or not, so initially this is the threshold, this is the 50th percentile, so the value should move from above 50th percentile to below 50th percentile. If this is the true, then we can say yes, we can start the flash drought identification from this point itself. This is the onset of the flash drought condition. So this is for the very first condition. If it is satisfied, we can go for the beginning of, or we can begin the flash drought identification. And then second, we will go for the second condition, that the mean decline rate of aridity index percentile should be greater than equal to 5%. And why we have taken 5%? We have taken from the literature. And why it is 5% or more? Because in the definition itself we say that flash drought is characterized by rapid intensification or rapid decline in soil moisture. So this 5% indicates the rapid decline in soil moisture at every time scale. So mean decline rate, it means every time step we are, if for example, if it is like for the very first it is 42 percentile, so the next one it should be minimum 5%, so it should be 37 percentile, then it should be 32 or less than 30 percentile. So every time step we have 5% decrease or more than this decrease. So this is the second condition. If this is true for one time, we can increase the time count like t equal to 1. If it is true for second time, we will increase the time count as t equal to 2, and we will go further once it is false. Once it is false, we will come for the third condition, that aridity index percentile should fall below 20th percentile. It means this value should fall below the 20th percentile. If it is going from this to this directly without going to below than 20th percentile, it means it is not a flash drought. This condition is also the mandatory condition. It should fall below 50th percentile, and finally it should fall below the 20th percentile. If this condition is true, we can increase the time count until unless this condition is true, and once it gets false, we have to go for the fourth and the final condition, that total duration, means here we are increasing the time count equal to t equal to 1, then t equal to 2, t equal to 3, and let's on. So if it is going like that, and if this total duration is equal to 3 or greater than 3, like 3 or 4 or anything, then we can say yes, that particular event is a flash drought event, otherwise it's not a flash drought event. Since our time step, one time step is equal to 8 days, so 3 time step minimum is requirement is 24 days. So if this condition is true for 24 days or 3 time step, then we can say yes, that particular event is a flash drought event. If it is false, we can say that that event may be a drought or not, we are not sure about that, but that event is not a flash drought event. So this is the condition of flash drought. In total we have 4 conditions. Initially we have to say that it must move from above 450th to below 50th, then it must have a rapid decline of 5% or more, then it should come below 20th percentile, because that is the second threshold which is very important to show the dry condition or arid condition, and finally it must agree or must true for 3 time step, and if it is true for that also, then we can say yes, that particular event is a flash drought. Otherwise it can be a normal drought like meteorological, hydrological, agriculture, we are not commenting on it, but we are very sure that it is not a flash drought. Okay, after that, once we have done this, then let's discuss some of the climatological characteristics across India, because if we are evaluating what is the arid condition across India, we must have some idea about the climatological characteristics across India. So in this we have plotted the spatial distribution of annual mean precipitation across India. Then the soil moisture we have plotted across India, that is the mean annual, not the daily basis data set. We have taken the mean of the annual data set across India for the precipitation, which is in mm per year. Then soil moisture here we have used in meter cube by meter cube, it means it doesn't have any unit. Then we have plotted the GPP, that is a gross primary productivity, to show the ecosystem indicator. Then we have used water use efficiency and underlying water use efficiency. So from the figure itself, I think you are working on Indian study area, so you all aware about the precipitation condition across India. You can see from the figure itself that annual mean precipitation over India is 300 to 650 mm per year, with a significant spatial heterogeneity, with a wide range of value which is ranging from less than 100 mm per year to more than 3000 mm per year. And this is the importance of India, that we are highly spatially and temporally heterogeneity we have. In some area we have precipitation which is very less, below 500 mm per year, and in some area we have precipitation more than 3000 mm per year. So this is the spatial and temporal heterogeneity we have across India in terms of precipitation and temperature. If we talk about the soil moisture condition or dry condition, we have very dry soil condition across central India and western India. If we talk about the GPP, we have the maximum GPP, maximum water use efficiency or maximum underlying water use efficiency across northeast India and western Ghat. And why it is so? Why we have maximum GPP, maximum water use efficiency across western Ghat or northeast India, and it is minimum across western India like Rajasthan? Is there any reason behind it? Vegetation or forest condition exists there. So water use efficiency is highest or higher for northeast India because that particular area is covered with the forest. However, in terms of western India, if we talk about, we have very low productivity in that particular area because we have high demand for evapotranspiration in western India like Rajasthan. So these are some of general results related to climatological variables across India. Then let's go for the flash dot. So here in this we are showing the results of frequency of flash dot, means the characteristics of flash dot across river basins of India. So in this we have divided the results or divided the frequency results into 4 seasons, because initially we have done for season like monsoon and non-monsoon, but the problem with this classification is that for monsoon we have 4 months and for non-monsoon we have 8 months. So comparing 4 months with 8 months is not the correct way to show the results, because obviously they are having 8 months, so it is completely double of that. So maybe frequency can come twice. So we can't say that in monsoon we have 4 events and in non-monsoon we have 8 events, because you are taking twice of the months. So you cannot compare with that. So that's why we have taken 4 different seasons as defined by the IMD itself. Even monsoon and non-monsoon is also defined by IMD, but here we have taken 4 seasons, that is winter season, pre-monsoon, monsoon and post-monsoon season. Winter season ranging from January to Feb, pre-monsoon from March to May, monsoon I think you all know that is June, July, August and September, and post-monsoon is from October, November and December. But when we are evaluating the result, we found that some of the events start in Feb like winter season and they are terminating or ending in pre-monsoon season. Some of they are starting in pre-monsoon and ending into the monsoon. So it is a very confusing stage that particular event is considered in which of the season. Either it is starting in winter and ending in pre-monsoon. So we need to consider in pre-monsoon or winter season. So it is problematic for us. So what we have done, we have also calculated the transition season. if a event is starting in one particular season and terminating into another season, so we have declared a transition season for that, and that event is considered into the transition season rather than any of the particular season defined by the IMD. So 4 events which are defined by IMD, then we have defined 4 different seasons. That is the transition from first season to second, that is winter to pre-monsoon, then transition from pre-monsoon to monsoon, monsoon to post-monsoon, or post-monsoon to winter seasons. So in total we have 4 by IMD, 4 by us, so in total we have 8 seasons. And in these results we found that during the monsoon season we found that majority of India is showing very low likelihood events of flash drought in the monsoon season, but the highest frequency of flash drought is observed in post-monsoon season, which is followed by the transition period of different periods. So why you feel that in the post-monsoon season or after the monsoon we have highest flash drought frequency? Because after the monsoon or like in the post-monsoon or non-monsoon season, we have long dry spells with negative precipitation anomalies, and this negative precipitation anomalies rapidly reduces the soil moisture, and this rapid reduction in soil moisture finally triggers the flash droughts to occur. So this is the reason that we have less flash drought in monsoon and high after the monsoon itself. Yes. Can you speak louder, please? Yes, for example, if we are talking about transition from winter to pre, we are considering January, February, March, April, May. Maybe it start in Feb and terminating into May. It may start in January and it may terminate into March. So all the 5 months of 2 season or all the 5 or 6 months of 2 season, it means this is a transition from winter to pre-monsoon irrespective of month. It can start from mid-Jan, it can end into the mid-March, mid-April or mid-May. We are not concerned with this. If it is going to start in one particular season and terminating into another season, we are creating the transition season for it. Why we are not creating the transition season from winter to directly to monsoon, like transition from winter to pre-monsoon, pre-monsoon to monsoon? Is there any question for you? Means we are creating a transition season from winter to pre-monsoon. We are not creating the transition season from winter to pre-monsoon and then it will come in, it will start in winter, it will end in monsoon. It will start in pre-monsoon and it will end into post-monsoon. Why it is so? Because flash drought don't have high durations like seasonal duration or year longer duration. For in that case we have conventional drought. Flash drought don't have high duration like seasonal duration or year longer durations. Then the second thing is that we have shown the flash drought intensification rate. Yes. I am unable to get. Dry spell. Okay, dry spell means the spell means this is here we are not defining the dry spell. Dry spell indicates that when we are not getting precipitation for a longer period, in that case itself it is showing the results, because it is showing these results in the after the monsoon or before the monsoon itself, not during the monsoon. So in the monsoon itself we have the precipitation, but in the non-monsoon season we have long dry spells, like for long months or 2 we don't have the precipitation, due to which it rapidly cause rapid decline in the soil moisture condition, because just after the monsoon, initially in the monsoon season we have high saturated condition of soil moisture. Once after that we have further very fast decline in the soil moisture condition just after the monsoon itself. So we don't have the precipitation, then soil moisture declines from particular value to lower value. So that creates a soil moisture reduction in a very fast or intensification manner, due to which it causes the flash drought to occur. So here we are defining the flash drought intensification rate, means at what rate soil moisture is declining at every step. So we found that the high intensification rate of flash drought are more common in humid regions like northeast India rather than semi-arid regions like western India. So this is same results which we have observed in the news clip for the England, that England studies clearly told us that even the damp condition or humid conditions are also hit by the flash drought. Here itself we found that humid area of India itself is experiencing the high intensification rate of flash drought rather than the humid arid or semi-arid regions of India like western India. And this suggests that anthropogenic climate change has altered the traditional climatic regions across India, and whenever if we are talking for normal conventional drought, we have different policies to address the normal drought risk. But if we are talking about the flash drought risk, we have to give more attentions to address the flash drought risk in humid regions or semi-humid regions rather than arid or semi-arid regions, because we have perception for the drought that if we have arid or semi-arid regions, they are more vulnerable to drought conditions. We are more vulnerable to drought conditions rather than humid or semi-humid regions. But in case of flash drought, it is not like that. It is completely different. It suggests that humid or semi-humid regions are more vulnerable because they have high intensification rate of flash drought across India rather than arid or semi-arid regions. Then the third important thing, we need to find out the triggers or the drivers which are causing flash drought to occur in India. So from the literature I got to know that some of the definition are using precipitation as an input variable to find out the flash drought. Some of them are using temperature and some of them are using soil moisture to define the flash drought. So we can say that all the three variables, either in terms of precipitation, temperature, soil moisture, all three are playing crucial role to define the flash drought. So we have taken all the three parameters like precipitation, temperature and soil moisture. However, it is also possible that precipitation along with soil moisture is causing flash drought. It may be possible that precipitation along with the temperature can cause the flash drought to occur in India. Or the third combination or the final combination is possible that all three are togetherly causing the flash drought to occur in India. So we have made 6 combination in total, like precipitation alone, temperature, soil moisture, then the combination like precipitation temperature, precipitation soil moisture, precipitation soil moisture temperature, and the combination of all three like precipitation plus temperature plus soil moisture. And the results declare that majority area, precipitation along with the temperature are major triggers or drivers of the flash drought across majority of the study area. However, in some area we have individual effect of soil moisture and precipitation acting as a trigger across some regions like northeast India. We have precipitation, and for northeast it is soil moisture. Then the third thing which we need to do is the soil moisture data set, because we need to use soil moisture to find out whether how our hydroclimatological variables are behaving during different stages of flash drought. For that we need soil moisture data set. But since we don't have observed or in situ soil moisture data set, so we have used this triple collocation approach to find out the best soil moisture data set for our study area. Initially I told that we have taken the soil moisture from 5 different sources. Out of that we have to find out the best one for us. So what we do, we will apply the triple collocation approach. So maybe I think you have heard about this triple collocation approach. This is a very good approach. It will not, for example, if we have 5 or 7 or any number of data sets we have, it will not treat any of the data set as observed truth. For example, sometimes we do the bias correction. We use IMD precipitation data set as observed data set, and we think that this is the correct data set for us. But in case of triple collocation, it is not like the case. We are not treating any of the data set as perfectly observed truth. Every single data set have its own value, and we are treating every data set at the same things. We are not treating any of the data set as perfectly observed truth. So why its name is triple collocation? Because at the same time we are analyzing 3 data sets at the same time. You can see from all the figures, for the very first figures we have taken 3 data sets, that is 1, 2, 3. Then we have taken 1, 2, 4. Then we have taken 1, 2, 5. Then we have taken 1, 3, 4. At the same time we are taking 3 data set. For every same time we are calculating the R square value and correlation coefficient value. How? For example, we have taken the first, second and third data set at the same time. then we will use of these three values, we are defining a unknown truth using these three values. Means we have three data set of soil moisture 1, 2, 3. Out of combining all these three, we will create an unknown truth, and based on that unknown truth, we will find out how the first data set is varying, significantly varying from that unknown truth. Then we will check the relationship of second data set with unknown truth. Then we will check the third data set with this unknown truth, and we will find out the RMSE value or correlation coefficient value, R square value we will find out here. Based on that, we found that in all the results we found that GLDS data set and ERA data set is performing better as compared to the other three data sources. So we can say yes, we can use this. However, we have to use one. So we compare GLDS and ERA data set, and we found that on a very finer resolution, GLDS is performing better as compared to ERA data set, and the reason is ERA data set has some missing value due to which it is not performing better than GLDS. So in this study we have used GLDS 2 version NOAA soil moisture was further used in this analysis for the drought classification. So this is my second sub-objective of this study, that here we are showing that how hydrometeorological variables are behaving during different stages of flash drought. Why this objective is required? Because if we have flash drought and defined by the aridity index, we have to calibrate that value. We have to calibrate that definition, or we have to validate that definition whether it is correct or not. So we know that we have to define the variables. So here we have taken four variables. The first one is the soil moisture, second we have taken precipitation, third we have taken soil moisture, temperature, and fourth one is vapor pressure deficit. And we have defined four stages of flash drought. The first one is onset, before onset, means before the flash drought occur or starts. The second one and third one is the onset and recovery condition, or we can say during the flash drought, before the flash drought, and this is the after the flash drought. We have to find how the different hydroclimatological variables are behaving during different stages. So if we talk about soil moisture, before flash drought occurs, the soil moisture percentile is in very good stage, that is across around 50th percentile. But once it enters into the flash drought, once the onset of the flash drought starts, once the value started or enters from above 50th to less 50th percentile, from 50 percentile it reaches to 41 percentile, just start of the flash drought. After that, once it enters into this recovery stage itself, this 41 percentile reaches to 90th percentile. It means from very good soil moisture conditions, we have a quick transition to much drier condition. And once after the recovery or once after the termination of flash drought, this is recovered from 90th percentile to 36th percentile. It means we can say soil moisture recovers very quickly after the termination of flash drought. If we discuss about the precipitation itself, I think from the figure itself you can see that during the flash drought the precipitation is in negative form, but before and after the precipitation is recovering very fastly. So we can say that flash drought are indicated or characterized by well below normal precipitation during the flash drought, but before and after it is not below the normal precipitation. Similarly goes with the temperature and vapor pressure condition, that during the flash drought this is having high temperature condition, but before and after the flash drought the temperature condition is not very high as compared to during the flash drought. So it means during the flash drought soil moisture is declining very fastly. It is showing very drier condition. If we talk about the precipitation, it is very less. If we talk about temperature, it is very high. If we talk about vapor pressure deficit, it is very high. It means all the variables are validating the definition of aridity index to define the flash drought. That during the flash drought we have less percentile of soil moisture condition, we have less precipitation, we have high temperature, we have high vapor pressure deficit, and also we are expecting the same for the definition if we are developing like this. Then the fourth part or third part of this presentation is that how our ecosystem is responding to flash drought. If flash drought is occurring, how we can define that flash drought is our ecosystem is responding to flash drought event or not. So we have two indicators to define whether ecosystem is responding to flash drought or not. The very first parameter to show that ecosystem is responding or not. So first one is response frequency and second one is the response time index. So in a very layman terms, we can say after how response frequency means how frequently our ecosystem is responding to flash dot event, and after how much time our ecosystem is responding. For example, if we have a flash dot, if we have 4 flash dot, our ecosystem is responding to all 4, or our ecosystem is responding to 3 or 2 or 1 event, or it is not responding none of them. Second thing, if it is responding quickly, or it is responding after taking some time to respond. So these are 2 variables or indicators we will calculate for that. So here we have shown the response of gross primary productivity to the flash dot events. So we have shown the response frequency and response time. So we have no substantial difference in terms of response frequency, but we have seen some longer response time in northeast India, or this part, Indo-Gangetic plain. So I ask you whether this longer response time is good for us or bad for us. Ecosystem should take more time to respond to the flash dot, or it should take less time to respond? More time. Why? Because if it will take very less time, it means it get easily affected by flash dot. If it is taking longer time, it means it have high resistance, so it will not get affected very easily in a very short period of time. But if it exists for more periods, we don't have any idea about that. So to get the better clear picture, here we know that longer response time is showing. It means this Indo-Gangetic plain have lower risk to the ecosystem. They have lower risk to the flash dot because they are taking longer response time to respond the flash dot events. So let's understand at what period of time our ecosystem starts affecting. So for that we have calculated the water use efficiency or underlying water use efficiency and their response to flash dot. So here you can see 2 important findings. Initially we have shown water use efficiency in this and underlying water use efficiency in this, and I declared the use of underlying water use efficiency in the methodology section, that if we are taking vapor pressure deficit, then that water use efficiency is known as underlying water use efficiency. So you can see that water use efficiency value are always lower as compared to this, and this is due to vapor pressure deficit. The important finding in this study is, or in this result is, that you can see that this part is showing the initial phase of the flash dot, and this is showing the recovery stage of the flash dot. If we talk about the initial phase, the value of water use efficiency or underlying water use efficiency are higher. However, these are going to be declined here. Means initially value are higher, but these are decreasing at the end or during the recovery stage of flash dot. What this high value indicates? The high value of underlying water use efficiency or water use efficiency indicates that our ecosystem is highly resistive or highly adaptive to the flash dot risk. But this resistance or this adaptation is going to be decreased with increase in the flash dot duration. Initially it is showing high resistance, but this resistance is decreasing due to increase in the flash dot duration. So this is the finding of these results. So finally we can conclude that based on this study we can say that aridity index can be a useful indicator to define the flash drought across India, because it is highly validated by the climatological variables also across different stages of flash drought. Second, if we talk about the intensification rate of flash drought, they have high intensification rate in humid regions rather than semi-arid regions. So we need to give more attention. We need to develop more better policies for the flash drought in terms of humid regions or semi-humid regions rather than arid regions. Whatever the policies we have for the traditional drought, we can't use for the flash drought also. We have to change it because they have high intensification rate in humid regions rather than arid regions or semi-arid regions. If we talk about the triggers or the drivers of the flash drought across India, we can say majorly the precipitation, means lack of precipitation and high of temperature are the major triggers which can cause the flash drought across India. However, some parts have individual effect of soil moisture and precipitation itself. Next thing is that if we talk about the ecosystem response, our ecosystem is highly responsive, means more than 97% of flash drought are responded by the ecosystem. For every single event, our ecosystem is sensitive it is responding to every single event. It means we can't say that flash drought is not affecting our ecosystem. For every single event, our ecosystem is affected. How we get to know that our ecosystem is affected? Because we are taking GPP value. If during the flash drought that GPP value is going to be decline, it means our ecosystem is responding to the flash drought. Due to flash drought condition, that GPP value is going to be decreased. So that is the response of that. And if we talk about this vegetation adaptation, initially we see that water use efficiency value are very high in the initial stage of flash drought, but these value going to be decreased in the later stage of the recovery of the flash drought. It means initially our ecosystem is highly resistive. It is showing better vegetation adaptation to the drought condition, but this is going to be decreased. It means our ecosystem resistance power is going to be decreased with increase in the flash drought condition. In this condition, we have used top 1 meter soil moisture data set as a root joint soil moisture, but since we got to know from the reviewer that sometimes we have plants which have roots deeper than 1 meter. So this study is also applicable to that particular crops or not, because here we are taking only 1 meter. Some plants have roots deeper than 1 meter, for example up to 1.5 or like that. So can we use for that also? So we have done all the methodology part again for the 2 meter, and we found that results are very similar. So no need to take 2 meter soil moisture data set again. So it's reasonable to use 1 meter soil moisture data to analyze the impact of flash drought. And these results are very helpful whenever we develop the effective or mitigation plan for the flash drought risk reduction strategies for India. And this paper was published in Journal of Hydrology, and also the second part of this study has been published in Journal of Hydrometeorology in 2024 itself. Thank you. So any questions? Yes, please. Yes, during the monsoon it is very less. After post monsoon it is very high. For example, if we have monsoon across any particular area and we have break in the precipitation for so long, like for a month or 30 days or more than 35 days, then obviously, because initially when the rain come in the starting of the monsoon, the soil moisture condition got improved, and after 35 days continuously we are not getting the precipitation, so obviously the soil moisture condition starts declining in that 35 days, and that if there is a rapid decline, so obviously it can cause the flash drought in that monsoon period also. Yes, but minimum it requires 24 days to occur. For example, if you are having the precipitation every 5 days, then I think soil moisture will not show high decline in the soil moisture conditions. So it minimum needs 24 or 30 days or more than that, so that it have high decline in the soil moisture condition for continuously 24 days itself. Otherwise, if you have precipitation after 15 days itself, so obviously the soil moisture will not decline up to 20th percentile. It may just regain its soil moisture condition, and it from, for example, from 38 or 30 or 25, it will regain to 30 percentile. So it will not go below the 20th percentile. So it will not cause the flash drought. But if it will go for more than 30 days like that, and it can go below the 20th percentile, so obviously it can cause flash drought in the monsoon period itself. Any other question, please?